Light is energy, made of electromagnetic waves. There are 7 different types of electromagnetic waves, all of which are shown on the electromagnetic spectrum. If not blocked, light can travel up to 300,000 kilometers per second. Unlike other waves, light does not need a medium to travel through. Light that is visible to the human eye is called visible light. It is just one range on the electromagnetic spectrum. A light bulb, for example, is visible light. The rays to the right of the visible light have the shortest wavelength but the highest frequency, while the rays to the left have the longest waves but lowest frequency. The visible spectrum of light on the electromagnetic spectrum interacts with the eye. Light receptors are a type of neuron in the eye that help us see color correctly. When the ray's wavelength is in the visible spectrum, humans can see light. The speed of light can travel through a vacuum. A vacuum is a volume of space that has no matter. Light was thought to be the fastest energy. However, scientists have recently found a new energy called neutrinos, which they claim is faster than light. This is going to make a huge impact on the way we think about physics. A pinhole camera is made up of 3 main things: a light-proof box, photo paper, and of course, a pinhole. A pinhole camera works by light rays traveling through the pinhole and projecting itself onto the back of photo paper. When you take your photo out, it appears to be upside down. This is because the light rays travel straight. You will also notice that your photo is a negative, and that is because of the way the light hits the photo. Because of the photo being a negative, you will notice how the places that should be white are now dark gray or black. This is because of the exposure.
The distance an object has to be away from the camera in order to fit the whole object in the picture is called the optimal distance. In this example, we are assuming that the height of the object, represented by HO, is 100 centimeters. The distance from the pinhole to the photo paper is 10 centimeters and is represented by dp. The photo paper, or the back of the camera, is 12.7 centimeters, represented by HP. What we do not know and want to calculate is the DO, or optimal distance. So, what do we know thus far? We know that HO is 100 centimeters, HP is 12.7 centimeters, and DP is 10 centimeters. The only thing we don't know and we want to figure out is the DO. We will solve this by setting up a proportion and solving for DO. We will start by plugging what we know into the proportion. After solving the proportion, we will know that the optimal distance is 78.7 centimeters. A modern camera consists of 3 main elements: a lens, a film, and a box that lets no light in. The aperture plays a very important role in taking pictures and how your picture will turn out. The aperture is a hole that lets light into the lens and then into the camera. Depth of field is how much your camera can see and focus on. A camera with a small aperture has a greater depth of field, and vice versa. So if you want to take a picture of a flower, for example, and you want the background to be blurry, you would want a bigger aperture. But how does this work? Lenses are basically a piece of glass that refract or bend rays of lights. This causes the rays of light to travel in a different direction than they would have if it wasn't for the lens in their way. Lenses are used in cameras to take the light in front of them and manipulate them to point to the film inside. If the aperture is small, then it makes the light rays traveling through the lens all point towards one specific area, making both the background and the foreground focused. If the aperture is bigger, it gives the rays of light more room to bounce around in the camera, which is what causes blur in pictures. The eye is similar to the camera in many ways. The iris, the part surrounding the pupil, serves as the aperture. It regulates the amount of light entering. On the outer layer of the eye, there is a see-through layer called the cornea, and at the back of the eye, there is a tissue called the retina, which is very sensitive to light, which is much like the film at the back of the camera. The light travels through the cornea and the lens, which works just like a camera's lens. This lens refracts the light so that it can be focused on the retina. The retina is much like the film in a camera because in both systems, the lens refracts the light and focuses it onto the film, or retina. The image on the retina will end up upside down because the rays of light you are looking at are traveling straight, so something that is below you will end up being on top of the retina. But not to worry, our brains flip the image around so we don't walk around seeing everything upside down. Did that make sense?